Hello everyone. Today we will be doing few questions on midpoint theorem and its converse. So we know that it's a very important theorem and it has got lots of application. So today we will be discussing few questions from the textbook of grade 9 Concise Mathematics by Selena. Alright. So this is chapter number 12. So before starting few questions, let's quickly recall midpoint theorem and its converse. Okay, and those who want to see the complete theorem with the proof can check the video in the I button. Alright, now let's quickly revise these two theorems because it's very important to understand like in which question you have to use which theorem. So unless you are not clear about these two theorems, you will be confused, right? So let's quickly revise. So in any question, if two midpoints are given, it means that you have to use midpoint theorem, right? So what is the midpoint theorem? Let's say there's a triangle and if two midpoints are given, let's say D and E are the midpoints of AB and AC, right? D is the midpoint of AB and E is the midpoint of AC. So the line joining these two midpoints will be parallel to BC and DE will be equal to half of BC. This is your midpoint theorem. I'll repeat. In a triangle, if two midpoints are given, then DE will be parallel to BC and DE will be equal to half of BC. That's it. Now, in converse of midpoint theorem, only one midpoint will be there. Okay. So let's say there is a triangle ABC. Okay. So here let's say D is the midpoint of AB. Right. So only one midpoint will be there. And from that midpoint, if there is a line parallel to another side, right? If there is a line parallel to another side, then DE will bisect AC. Okay. So I'll repeat. So in a triangle, if only one midpoint is given and through that midpoint, if there is a line parallel to another side, then that line will bisect the third side. Okay. So it's very easy to identify. For midpoint theorem, two midpoints will be there. And for converse, one midpoint will be there and through that midpoint, if there is a line parallel to the another side, then you can use converse of midpoint theorem, right? Now let's see few questions of exercise 12a. So the first question is, in triangle ABC, M is the midpoint of AB. So let's take a triangle ABC and here M is the midpoint of AB and a straight line through M and parallel to BC. So from here draw a straight line parallel to BC. Cuts AC at N. Cuts AC at N. Find the lengths of AN and MN. So you have to find the length of this AN. This you have to calculate. And MN. AN and MN. So this is your MN. If BC is 7 centimeter, so this BC is 7 centimeter and AC is 5 centimeter. So this AC is 5 centimeter. So what is given? Triangle ABC is given. Given triangle ABC where M is the midpoint of AB, right? So M is the midpoint of AB and here MN is parallel to BC. MN is parallel to BC. Okay. Also they have given that AC is 5 centimeter and BC is 7 centimeter. And you have to find out AN and MN. Okay, so I think the question is clear. So as I told you that here in this question you have to see how many midpoints are given. So here only one midpoint is given. And the line through this midpoint MN is parallel to BC. So one midpoint is given and through that midpoint there is a line parallel to another line. So which theorem you have to use? Yes, you will use converse of midpoint theorem, right? So let's write down. So in triangle ABC, M is the midpoint of AB and MN is parallel to BC. This implies MN bisects AC. So MN bisects AC, which means what? That AN will be equal to NC, right? This implies AN will be equal to NC. Also you have to write down from converse of midpoint theorem. Now AN will be equal to NC. It means that we can say that AN is half of AC, right? So AN is half of AC and AC is 5 centimeter. So half of 5 centimeter will be 2.5 centimeter, right? So AN is 2.5 centimeter. Now next you have to find MN, right? Now since M is the midpoint of AB and N is the midpoint of AC, so we can conclude that MN is equal to half of BC, right? So you can write down also MN is equal to half of BC, and BC is how much? BC is 7 centimeter, so you will get 3.5 centimeter. So MN is 3.5 centimeter. So I hope this is clear to everyone. This was a very simple question. Now let's see the second problem. Now in this question, you have to prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle is a rhombus. So what does it mean? See, read once again. Prove that the figure obtained by, how we are getting the figure? Figure obtained by joining the midpoints of the adjacent sides of a rectangle. It means there is a rectangle already, right? A rectangle is given and we have to take the midpoints of all the 4 sides of the rectangle and we have to join all these 4 midpoints, right? So after joining these midpoints, whatever quadrilateral you will get, so that quadrilateral, it means this quadrilateral is a rhombus. This is what you have to prove. So let's name it P, Q, R, S. I'll repeat once again. Prove that the figure obtained by joining the midpoints of the adjacent sides of a rectangle. So I have joined the midpoints of the adjacent sides of this rectangle, right? And I got this quadrilateral PQRS. So I have to show that this quadrilateral is a rhombus. Okay. Now you should know what is rhombus, right? Otherwise, how you will show that, PQRS is a rhombus? So we know that rhombus is nothing but a special type of parallelogram where all the sides are equal to each other, right? So here in this case, to show that PQRS is a rhombus, first you have to show that PQRS is a parallelogram. Okay, because rhombus is nothing but a parallelogram where all the sides are equal. Fine. So first you will show PQRS is a parallelogram. Second, you will show that any one pair of adjacent sides, are equal. Now what is the meaning of this? See, in a parallelogram we know that opposite sides are equal to each other, right? So if I show one pair of adjacent sides, so you can take any one pair, let's take this and this, okay? If I show that these two sides are equal to each other, so don't you think that all the sides will become equal to each other, right? Because this is equal to this. In a parallelogram, this is equal to this and these two sides are equal to each other. So if I show that these two are equal to each other, so automatically all sides will be equal to each other, right? And you can take any pair of adjacent sides. You can take this and this, or this and this, any pair you can take, right? So basically here our aim is to show that PQRS is a parallelogram. Any one pair of adjacent sides are equal. Okay. Now how to show that a quadrilateral is a parallelogram? Again, there are three ways of showing a quadrilateral is a parallelogram. You can show in three ways. So what are those three ways? You can choose anything. See, the first method is that in a parallelogram, if you show that only one pair of opposite sides are equal and parallel, then it's a parallelogram. Alright, so the first way is, if you show that any one pair of opposite sides are equal and parallel, then the quadrilateral becomes a parallelogram. Alright, so let's take a quadrilateral ABCD. So in this quadrilateral, if I show that AB is parallel to DC and AB is equal to DC, so this is enough to show that this is a parallelogram, right? Now what is the second way? So second way is, you have to show that two pairs of opposite sides are parallel. Okay, so it means what? It means that in a quadrilateral you have to show two pairs of opposite sides. So let's take AB and DC. These are opposite sides. So if you show that these two are parallel, and if you show AD is parallel to BC, if you show this much, then this becomes a parallelogram. Also, if you show two pairs of opposite sides are equal, then also the quadrilateral becomes a parallelogram. Alright. So if you show that in a quadrilateral these two sides are equal and these two opposite sides are equal, if you show this much, then also it becomes a parallelogram, right? So there are three ways of showing any quadrilateral a parallelogram. Now let's use this first method to show that any quadrilateral is a parallelogram, right? So here how do you show that it's a parallelogram? So basically we have to show either PS and QR are equal and parallel to each other, right? Or you can show PQ and RS are equal and parallel to each other, right? So it's up to you, you can choose anything. So if you join AC, then we will show that QR will be parallel and equal to PS, right? Now, if you notice that Q is the midpoint of AB and R is the midpoint of BC, right? So here we can see that two midpoints are given, right? If you take triangle BAC, in this triangle, Q and R are the midpoints, right? So which theorem you will use? You will use midpoint theorem. So as per midpoint theorem, QR will be parallel to AC and QR will be half of AC, right? Also, you can see in the other triangle, triangle ADC, in this triangle, P is the midpoint of AD and S is the midpoint of DC, right? So PS is the line segment joining the midpoints. So PS will be equal to half of AC and PS will be parallel to AC, right? So what did we see? That PS and QR, they both are parallel to the same line and they both are equal to the half of same line. So it means that PS and QR will be parallel to each other and they will be equal to each other, right? So we have shown that PQRS is a parallelogram, right? Now this part is done. Now second part. Okay, before doing second part, let's write down first part and then we'll move to the second part, right? Okay, so first let's write what is given. So here ABCD is a rectangle and what else is given? Yes, P, Q, R and S are midpoints of AD, AB, BC and CD respectively. Okay, so only this much is given and you have to prove that PQRS is a rhombus. So PQRS is a rhombus. Okay, so here you will do construction. So before proof, you have to write down the construction. So construction is join AC. Alright, now in triangle ABC, Q and R are the midpoints of AB and BC, right? So this implies QR will be parallel to AC and QR will be equal to half of AC from midpoint theorem. Alright. Now, similarly, you will take the other triangle. So, triangle ADC, in triangle ADC, P and S are midpoints of AD and DC. This implies PS will be parallel to AC and PS will be equal to half of AC, right? This is also from midpoint theorem. Now from, let's say this is your 1 and this one is 2. So from 1 and 2, what we can conclude? From 1 and 2, we can say that PS is parallel to QR. PS is parallel to QR and PS is equal to QR, right? Isn't it? Because PS and QR, they both are parallel to AC, right? So they will be parallel to each other. And QR and PS, they both are equal to half of AC. So it means what? That QR and PS will be equal to each other, right? So this implies that PQRS is a parallelogram because we have shown that one pair of opposite sides are equal and parallel, right? Okay. Now the second part, we have to show one pair of adjacent sides are equal. So how we will show this? So whenever you have to show that angles are equal or sides are equal, so which concept comes to your mind? Which concept comes to your mind? The concept of congruency, isn't it? So we can use the concept of congruency here to show that let's say let's take QR is equal to RS. We will show QR is equal to RS. Now since QR is a part of triangle QBR, right, and SR is a part of triangle SCR. So if we show that these two triangles are congruent, then we can say no by CPCT that QR will be equal to RS, right? So now first see whether you can show the two triangles are congruent or not. So yes, we can show that because this angle, angle B is equal to angle C. Why are they equal? Each is 90 degree. It is given that ABCD is a rectangle, right? In a rectangle, the corner angles are 90 degree. Okay, now what else? Now R is the midpoint of BC, that is also given. So can I say that BR is equal to RC? Correct? Also, now QB, what about QB and SC? Are they equal? Do you think that QB and SC are equal? Yes, they are also equal, but we have to show how they are equal. See, we know that ABCD is a we know that ABCD is a rectangle, right? Now in a rectangle, the opposite sides are equal, correct? So AB will be equal to DC, and Q is the midpoint of AB and S is the midpoint of DC. So half of AB, which is QB, will be equal to half of DC, which is SC, right? So QB will be equal to SC. So we have shown that these two triangles are congruent. So by CPCT, we can say that QR is equal to SR. It's very simple. Okay, so let's write down this information. So you have to take triangle, in triangle QBR and triangle SCR. In these two triangles, angle B is equal to angle C, each 90 degrees. Then BR is equal to RC. It's given. Then QB is equal to SC. But you have to give a reason why they are equal. Okay, so you have to show here. Either you show this before and you can just write here proved above, or you can just show the proof here only. Okay, so we can write down here that AB is equal to DC, right? Because ABCD is a rectangle. ABCD is a rectangle, right? Now half of AB will be equal to half of DC. I divided both from 2. Okay, so half of AB. Now how half of AB is QB and half of DC will be SC. Why? We can give the reason because Q and S are midpoints of AB and DC respectively. Okay, so you have shown here like why QB is equal to SC. Now you have taken one angle, one side and one more side, right? And you please check like in which sequence you have taken here. So you have taken this side, then angle and this side, right? So this is SAS. So triangle QBR is congruent to triangle SCR by SAS congruency. Okay, so this implies that QR will be equal to RS by CPCTC. Okay, therefore PQ RS is a rhombus okay, therefore PQRS is a rhombus. We have shown that PQRS is a parallelogram and then we showed that QR is equal to RS. In this parallelogram, QR is equal to RS. Or you can, or before writing this statement, you can write down therefore in parallelogram PQRS, all sides are equal to each other. This implies PQRS is a rhombus. Alright. So this question looks a little long, but it is not difficult at all. Okay, you have to first show PQRS is a parallelogram, which you can show using midpoint theorem, and then you have to show any one pair of adjacent sides are equal, right? So I have taken QR is equal to RS. You can prove QR is equal to QP. So in that case, you will prove that these two triangles are congruent. Triangle QAP is congruent to triangle QBR. So in that case, you will say by CPCT, QR will be equal to QP. You can also show QP is equal to PS. In that case, you will take these two triangles. So it's up to you. Okay, you don't have to follow exactly this. You have to just understand the logic. Okay. Now let's move to the next question. So in this problem, D, E and F are the midpoints of the side AB, BC and CA of an isosceles triangle. So let's take a triangle ABC, and it's given that D is the midpoint of AB, right? So D is the midpoint of AB and E is the midpoint of BC and F is the midpoint of AC. So D, E and F are the midpoints of sides AB, BC and CA of an isosceles triangle ABC, in which AB is equal to BC. So here AB is equal to BC, and we have to prove that triangle DEF. So when you join these midpoints, you will get one triangle DEF. So you have to show that this triangle is an isosceles triangle, right? So I hope the question is clear. Let's first write down what is given and what do we have to prove so that the question becomes more clearer. So triangle ABC is given, and here AB is equal to BC. What else is given? D, E and F are midpoints of AB, BC and CA respectively. Alright. Now what do you have to prove? You have to prove that triangle DEF is an isosceles triangle. Alright. So what is your construction? You have to join DF, FE and ED so that you get this triangle. Now how do we prove this? So to show that any triangle is an isosceles, you have to show that any two sides are equal to each other, right? So here, how do you show that in triangle DEF any two sides are equal? So for that, we will take a hint from here. For whatever is given from there, you will get a hint. See, it is given that AB is equal to BC, right? So in a triangle, if two sides are equal, then their opposite angles will be equal, right? So opposite to side AB is which angle? Angle C, correct? And opposite to side BC is which angle? Angle A. So don't you think angle A will be equal to angle C, right? Since angles opposite to equal sides are equal, right? Okay. Now since you can see that in triangle ADF, I am getting a part of this triangle, right? Correct. And in triangle ECF, I am getting a part EF of this triangle. So if I show that DF and EF are equal with the help of these two triangles, then my purpose will be done, right? Because I have to show what? I have to show that DEF is an isosceles triangle. So if I show that DF is equal to EF, then it's proved. Correct? So how to show that DF is equal to EF? So let's try to show that these two triangles are congruent, right? Triangle ADF and triangle CEF. Let's see whether we can show that these two triangles are congruent or not. So one thing, we got that angle A is equal to angle C, right? Now what is the second thing? Yes, F is the midpoint of AC. So even AF is equal to FC, right? Now the last thing. So now see which angle or which sides are equal in both the triangles. So whatever is given here, focus there. From there you will get your answer. Okay. Whatever is given, that is like a clue. That's like a hint to, to do the question further. So here, what do you think about AD and EC? Are they equal? Yes, they are equal. Now how they are equal? See, we know that AB is equal to BC. It is given in the question, right? And D is the midpoint of AB and E is the midpoint of BC, right? So half of AB which is DA and half of BC which is EC, they will be equal to each other. So DA will be equal to EC, right? So we have shown that the two triangles are congruent from side, angle, side. From SAS, the two triangles are congruent. So by CPCT, DF will be equal to FE and therefore DEF will be an isosceles triangle. Okay, so it's very simple. So let's write down whatever I have told you. So from where you will start? Okay, let's start proving that these two triangles are congruent. Okay, so in triangle ADF and triangle ADF and CEF. In these two triangles, angle A is equal to angle C. Now why they are equal? You can show here. You can write down. Why? Because AB is equal to BC. Right? Now next AF is equal to FC. Why they are equal? Because F is the midpoint of AC. You can write given or you can write down F is the midpoint of AC. Anything is fine. Now next is AD is equal to EC. Now this you have to show why they are equal. So you have to write down here because AB is equal to BC. It's given, right? This is given. Now dividing both sides by 2. Or you can say multiplying both sides by half. Anything is fine. Now half of AB is how much? Half of AB is AD and half of BC is how much? It's EC. Now why? Because D and E are midpoints of AB and BC respectively. Okay, so we showed that AD is equal to EC, right? Therefore, triangle ADF is congruent to triangle CEF by side angle side congruency. So this implies DF will be equal to FE by CPCTC. Alright. Therefore, triangle DEF is an isosceles triangle. So I hope it is clear to everyone, right? So let's recap quickly. what we did, we proved that these two triangles are congruent, right? And then we said by CPCT, DF is equal to EF. Only this much we have done, right? Now while proving the two triangles are congruent, we took angle A is equal to angle C. This is why? Because AB is equal to BC. If two sides in a triangle are equal, their opposite angles will be equal. Alright. Now what else we took? AF is equal to FC. Why? It's given. F is midpoint of AC. That's given, right? Next, the third thing which we took is AD is equal to EC. Now why they are equal? Because AB is equal to BC. D is the midpoint of AB and E is the midpoint of BC. So half of AB will be equal to half of BC, which is AD. AD is equal to EC. So we showed the two triangles are congruent by side, angle, side. Okay. So by CPCT, DF will be equal to EF. Okay. Now moving on to next question. Now let's see question number 4. So the question says the following figure shows a trapezium ABCD. So here ABCD is a trapezium in which AB is parallel to DC. So AB is parallel to DC. P is the midpoint of AD. So here you can see that P is the midpoint of AD. It means AP will be equal to PD. Alright, and PR is parallel to AB. So PR is parallel to AB. So you have to prove that PR is equal to half of AB plus CD. Alright, so first let's write down what is given and what you have to prove. So here it's given that ABCD is a trapezium, right? Where DC is parallel to AB and PR is parallel to AB. Okay, and what else is given? Yes, P is the midpoint of DA. So P is the midpoint of DA or AD, anything you can write. And you have to prove that PR is equal to half of AB plus CD. Now see, it's given that P is the midpoint of DA. Only one midpoint is given, right? And they have given PR is parallel to AB. So one midpoint is given and here information about parallel lines are given, right? So which theorem you will use? Converse of midpoint theorem, right? So here you will take triangle DAB. In this triangle, P is the midpoint of DA and it's given PR is parallel to AB. So I can say that, no, that PQ is parallel to AB, right? Correct. So from converse of midpoint theorem, I can say that PQ will bisect DB. It means Q will be the midpoint of DB. Alright. Okay. Now also PQ will be equal to half of AB. Right? Isn't it? Now this will be your first part of the answer. Now the second part, you will take triangle BCD. Okay, this triangle you will take. Now in this triangle, if you see Q is the midpoint of BD, just now we prove it, right? Also, do you think that QR is parallel to DC? Yes, they are parallel. Why? Because it's given that AB is parallel to DC, AB is parallel to DC, right? These two lines are parallel. Also, it's given that PR is parallel to AB, PR is parallel to AB. Now, this line is parallel to AB, this line is parallel to AB. These two lines are parallel to the same line. It means what? That these two lines will be parallel to each other. Correct? So, I can say that QR is parallel to DC. Right? So, what did we observe in this triangle? In triangle BCD, in this triangle, Q is the midpoint of BD and QR is parallel to DC. So, what can we conclude? So, we can conclude that from converse of midpoint theorem, even R will be midpoint of CD. Right? and QR will be half of CD, right? QR will be half of CD. Now, from these two, when you add this result and the previous result, you will get your answer. Proof is, first take triangle DAB. In triangle DAB, P is the midpoint of AD and PQ is parallel to AB, right? This is given. This implies PQ will bisect DB, right? From converse of midpoint theorem. So this is very important to write down, okay? Now, also you can conclude that PQ will be equal to half of AB, right? Because now P is the midpoint of DA and Q is the midpoint of DB. So we can say that PQ is equal to half of AB, right? So this you can name it 1. Now similarly, you will take the other triangle. So write down in triangle BDC. Now in this triangle, what do you observe? Again, you can write down that Q is the midpoint of DB. We just proved it, right? And QR is parallel to DC, right? Now why they are parallel? Here you can write down the reason, because AB is parallel to CD, right? It's given there. AB is parallel to CD. AB is parallel to, let's write DC. AB is parallel to DC. And PR is parallel to AB. PR is parallel to AB. So this implies that QR will be parallel to DC. Okay. So this reason you can write down here. Now Q is the midpoint of DB and QR is parallel to DC. This implies that R will be the midpoint of CB, or you can say QR will bisect BC. So this implies QR will bisect BC. Again, from converse of midpoint theorem. Alright. So, also we can say that QR will be equal to half of DC. Correct. Now let's take this as number 2. Now if you add 1 and 2, how much you will get? So adding 1 and 2, let's see how much we get. So you know how to add, we add the LHS with the LHS. So PQ plus QR. PQ plus QR. PQ plus QR will be equal to, now add the RHS, half AB plus half DC. So can I take half common and I can write half AB plus DC. I can write like this, right? Now PQ plus QR, you saw that we will get PR. So this is equal to PR. And here, just copy it as it is, because this is what we have to prove, right? If you see, this is what we have to prove. PR is equal to half AB plus CD or DC. Anything you can write. So let's write CD. So you can see that this question is very simple. So here basically in all these questions you have to identify which theorem to use. So based on the previous question, let's try one question. So let's say there is a trapezium A, B, C, D, and P is the midpoint of AB and Q is the midpoint of DC, right? Also AD is 4 centimeter and BC is 10 centimeter. Okay, so this much is given and you have to find the length of PQ. So how you will do that? So just now we did in the previous question that PQ will be equal to half of AD plus BC, half of BC. Okay, so here AD is 4 centimeter and BC is 10 centimeter. So you will get half into 14, which is 7 centimeter. So here the length of PQ will be 7 centimeter. So this relation is true only when a trapezium is given and the midpoints of the non-parallel sides are given. Alright, so then only this condition holds true. So you can use this formula to find the length of PQ. So that's it for today. I will be doing few more questions in my next video. So keep practicing. Until then, take care, stay safe.